Hello and welcome to yet another video. Today's topic for our focus chat is code reviews. I'm Alex Bolbaka. I'm coming to you from the Mosaic Work Studios, and as usual with me is Adi.
Hello.
So the topic of code reviews has come up recently in the latest edition of CppEurope a few weeks ago, and I thought it would be interesting to look around a bit on what is documented today about code reviews and how people are doing code reviews today, because I think there are quite a few problems. So a few problems that I've seen is a complete focus on tools.
Yes.
And not too much on interaction or conversations. And so it would be interesting to go through a few ideas. How have you done code reviews in the past?
Side by side, like pairing. Typically 90% probably of the time that was the situation. And the rest of the 9% was remote pairing. So not side by side, but having the pair in front of the computer of the same code, but remote. And we would look at the same code via screen sharing or other better tools for pairing. And yeah, maybe just a few times giving out ideas offline, so not being in the same room or in the same virtual room together.
I've done the same. So, and it's a bit puzzling to me how people prefer to write comments, like to get a pull request that is sometimes very long, hundreds of lines long, and
Yes.
then write comments back and forth instead of having a conversation. I think actually one of the things that helped us is that we always defined coding guidelines as a baseline for this. And so,
Yeah.
First of all, we had things like how to structure your code visually, like tab spaces, whatever, where to put the semicolon, where to put the curly braces and all that stuff. And this was automated, so we never discussed those things. Those were just built into the tools. So you do auto format and that's all. You got everything right.
Even more, you could put linters and then it's even better. So.
Yeah, then you have some tools. And with tools, I think there's very important to pick what's most important for you. Because many tools, like if you take SonarQube and you run it on an existing piece of code or existing code base, you'd get like hundreds of errors and warnings and stuff like that. And then it's very discouraging to see this. So whenever I use these things, I just picked the rules that we are following. Because sometimes you wouldn't follow, some of the rules. Not all the rules are applying to every code base. And so this was the second one. And then a programmer would write the code, run the analysis tool, or it was run automatically, fix those things. Of course, write tests and make sure that things work and fix those things. Then keep in mind a few rules, the ones for clean code, the ones for, we also had the mantra of first make the code work, then make it clean it up, then optimize for performance only when needed. So first you measure and then you optimize. And And so with this being said, what's left for a code review in this case? Well, what's left is the important stuff. Design things. How the code is structured. Can you structure a bit easier, a bit different? What are the tests telling you about the code structure? And so on. So, but we weren't actually looking for, bugs, because most of the bugs were already sorted out through testing, through blinters, through perhaps some security tools. And then everything else was a conversation. And why is it a conversation? Because that's how you learn.
Yes.
Right. And I think this is what many people are missing. So when you are passing messages back and forth, you just want to get it done.
Yeah, and also, there's people have different purposes of these code reviews, because as you said, typically for us, the purpose is design or looking at how to improve certain things, or if something got missed during the development or parts of the development. But other people look at code review as a quality gate.
Mm-hmm.
And it's like, you're like a junior, or not junior, but almost junior, and we need to check your code because we don't trust you. So then we use Git, and you will need to make to put the code there, and then we'll use any sort of tool on Git to write comments, and we'll tell you where you did wrong. So this is how I see typically how I see the idea of code review being implemented.
And to be honest, this is how I started my career as well. I was given a lot of feedback through code reviews by people in other countries and so on. And it was C++, and we were following a bunch of rules there. It was very, very important to follow all those rules. It helped me learn those rules, but still it wasn't the best experience, right?
Mm-hmm.
All right, so I thought we would look at, I found a selection of articles on InfoQ. So if you are interested in code reviews, perhaps you can look here. But I found a few who draw my attention, and the first one is called 13 Practices for Better Code Reviews, written by Mohammad Ali Bozorgzadeh. I hope that's how you pronounce his name. Reviewed by Shane Hasty. And let's look a bit into it. I'll just switch to the reader view. First of all, I'm noticing this idea of change list. Organize your change list to be focused and as small as possible, but do not make it unreliable by putting the tests off.
Yes.
That already to me is a big a big problem. If you even wonder whether you're putting your tests off, then perhaps you have a bigger problem than code reviews, right?
But this thing with the big or small change set, I think this also is very present. I hear a lot like I need a code review for the things I've done for the last week, or for a task I kept working for 2 or 3 weeks. So I see this all over and over again. And you can imagine how difficult it is to have multiple files, multiple areas, to see the code, how it was changed, maybe changed and changed again. It's not fun to do code review like that. It's not efficient. It's not efficient even for the person whom you are reviewing.
I have an even worse one, which is when you are mixing reformatting with
Yeah, of course.
code changes, then
Yeah.
it's a whole mess. It's a whole lot of mess.
You cannot understand anything anymore.
Yeah. So that's true. There are large change lists, but the problem is that people don't know how to split, how to think incrementally and go to smaller pieces of functionality that are implemented and merged or submitted, or if you want to commit them, however it works for you. But yeah, the bigger problem is incremental thinking. So the challenge here is to figure out how to split into multiple change sets, right?
Exactly.
And the way I've done this in the past, actually, if you have, let's say I'm doing the review. By the way, in the teams that I worked, there wasn't one person doing the review. It's always review each other's code.
Mm-hmm.
Right. And when I was kind of the lead, I would do like a final review, but by then everything was good. I mean, I was just double checking for weird stuff at that point. And it was basically ready for production. So I wasn't worrying so much about it. I was mostly looking at design and things like that. But if you do this side-by-side code review, then the person who needs the review will actually present you the code and the code changes.
Yes.
And that is a good feedback for them to learn how to make fewer code changes or split the change sets, right? Okay. Provide a comment or refuse a comment you have received only if you have a reasonable argument. Create a culture based on arguments and free of complaints and blame. This is generally a good thing. Now, I feel that this happens more when you are communicating through text rather than being side by side and talking about your code.
Yeah.
Respect and help the review process by prioritizing review tasks over coding and certifying the reviewers. Now, this is pretty funny to me. So first of all, help the review process by prioritizing review tasks. Well, that depends.
It depends.
Yeah, on what you have to do. But yeah, so usually how it worked in small agile teams is you get a small increment of functionality to implement. It takes you 1-2 days, right? Maximum. And then you say, okay, I'm done. I need a code review. And because it's so small, the code review will take a short time. So it will only be like 15 minutes. Maybe 30 if you have a lot of things to discuss. But
Yeah.
so then it's easy to find this time. But certifying the reviewers, come on.
Yeah, well, I guess that means, so let's go into this scenario where, let's say you have 2 juniors, 2 mid, and a senior in a team. And what would you do? Would you let the juniors review the code or not?
Absolutely.
So then the question is, but they wouldn't understand the issues that mid or a senior would see. So why do you do that? What's the point?
The point is for them to learn good practices, right? Because if they focus on this, first of all, they need to look at the guidelines and to figure out, okay, these are the guidelines, this is the checklist that I'm looking at. Let's see how it applies to this code. And yeah, maybe they won't find some deeper design issues. But let's be honest, if you have 400 lines of code to review, you won't find any deep design issues there. Because it's much too long, right? So they won't find those, but at least they will learn and apply the guidelines, and then they will be able to apply the guidelines better in their own code when they write the code. So that's why code reviews should also be seen as a learning process for everybody. You learn as the person whose code is reviewed because you get feedback and you learn, okay, maybe I need to be careful with these few things. But at the same time, when you are doing the review, you learn the guidelines and you learn how to think about the code, which is something you don't do when you write the code.
Yes.
Right. So that's why I think this is silly. Now, if you have specific areas of the code that are very tricky, then by all means, I would still have this review process, this peer review actually, where anybody can. So basically what happens is somebody finishes their task and they say, okay, I need a review, who's free to review my code? And then they review each other's code. But then if that area in particular is trickier, or if you want to have like more control, more figure out if there are any issues, then you do a second review. Right? But you still preserve the learning within the team, because everybody will learn from everybody, and you make sure that they haven't missed anything that's trickier, right? And actually, let's go back to this, because I think it's also interesting what happens when an issue escapes the review. Right. So let's say you have a design problem. Nobody sees it. It goes in production. You figure it out 1 month later.
Yes.
And what should you do then? Well, two things. First of all, refactor.
Yeah, but you need to understand what you need to refactor. So
Of
probably
course.
you make a kind of an analysis of why the code, the bug got there, and what's the area of the code that you need to improve, right?
Exactly. So, and then this learning should go back into the guidelines. Right? Because if you've learned something new about whenever you have, and not necessarily bugs, but let's say design issues, like something is not as flexible as it should be, or we knew that we needed to add some more features, but when we get there, we figure out we need to rewrite or refactor a lot of the code that we wrote 1 month ago. Things like that. These are things you can document, right? And some of those can go back into coding guidelines.
Yes.
Because the coding guidelines can be on levels. They can be on, things that we do to avoid defects, things that we do to avoid security issues, things that we do to have performance, things that we do in order to have flexible design even in 1 month or 6 months, or things like that. These are all different levels of design guidelines, of coding guidelines, right? And part of those you learn by doing these reviews and figuring out what you missed.
Yes. So it's also having a defect is also a feedback on the fact that you maybe don't have complete guidelines or you miss something in the guidelines. It can be something operational. It can be something that just got missed. So that it can be many things.
Yeah, it can be that you need to write a specific test for specific things. Yeah, like, because that's one thing I also have with people who are doing test-driven development. In test-driven development, the focus is often on making the things work, right? And also refactoring. But I think some of them are missing that you also have some additional weird cases that you need to write as tests, right? So even if your code works with, let's say, general strings as inputs, or let's say you are doing, I don't know, you are doing the tennis game or something like that, and you have the player names, and you just test with the normal encoding, UTF-8. Now, in theory, this should work for any weird characters and so on. But once you've written those tests and everything works and it displays, the score, the tennis score and all that, I would still want to write a few more tests that actually document that things work with diacritics in Romanian, with French characters, maybe with Chinese characters, maybe. And most likely those tests will pass. But sometimes they might fail. Right? And these are the things that you discover later on, usually. Because
Yes.
you had some assumptions.
So that's why I said it's a kind of feedback, and it's never perfect when you start. You need to understand that, and it's fine to have every once in a while such the feedback. The issue is if you have too many of them, so then you have a structural problem.
Absolutely. If you have hundreds of bugs, then you have a bigger problem. Although, another thing that should be said here, if you have a lot of bugs, a very powerful technique is to do a root cause analysis on the bugs. Because it turns out that the bugs distribution is not uniform in your code. Bugs tend to cluster. So what this means is, if you find out what you're doing wrong for 3 or 4 of the bugs, it is very likely that you'll figure out 80% of your bugs. And the way to avoid introducing similar bugs in the future. So this is yet another feedback cycle, right? Let's say we have bugs that escaped everything, and the user found it. So the worst kind of bug. But then look back and figure out, okay, so what's the root cause? What do we need to change? Do we need to add another rule in SonarQube, or do we need to add another guideline, or do we need to pay attention at code reviews at something, or do we need to write more tests on something? Or just not use certain code structures.
Yes.
Right. So these are things that can work, are very, very powerful. All right. So I don't agree with certifying the reviewers. This is silly. It doesn't help. It blocks learning. And learning is the most important thing you can do with code reviews.
Yeah.
You can do quality, yes, but actually learning how to avoid similar things in the future is much more important. Because imagine that, let's say you have a possibility of having, 1,000 types of issues. in the beginning. You eliminate some of those through testing, through static code analysis, and then through code reviews. But even then, at code reviews, you'll find, let's say, a few hundred of those. Now, if everybody in the team learns how to avoid those, then in a few months, in a few years, your code reviews will be faster, and you'll have less issues remaining, because there's fewer things to actually sift through as potential challenges. And of course, it's a bit more complicated, because when you are starting with a new technology, there's a whole new other set of issues that you potentially introduce. So so it's not linear, but it is the right process to follow. Okay. For tough and challenging issues, consider oral conversations and pairing with the reviewers. Use tools to detect routine and simple issues. So I agree with this, except that oral conversation should be...
most issues, I guess.
Yeah. Conversation should be the most. And we also had another rule, which is if you did pair programming, then the code is considered reviewed already. But you also need to know how to do pair programming, right? Because if pair programming is one person writes and the other reads Facebook on the phone in the meantime, then that's not pair programming.
Yes.
Use tools to detect routine and simple issues, yes. Review everything you consider as a developer is in your scope as a reviewer. I would say even more than what you consider as a developer. Because as a developer, you might forget about things like security, about things like what will happen in 6 months with this code. You might not want to write tests. I've heard that there are people like that.
Yeah, not many, but there still are.
I think unfortunately it's the majority, but yeah. Right, so this is, okay, the article is much longer than this, but that's the essence. I think another thing, and we actually did a video on this, is remember that you are not your code.
Yes, of course.
When somebody gives you feedback on your code, it's about your code, it's not about you.
Mm-hmm.
And this is very important. What else would be here to say? Tools take such as a burden. Reviewer should be fine. No. The mediator should follow the same culture. Oh, so now you need a mediator to...
I don't understand what's a mediator. Oh, when you have an argument, because... Oh, no way.
Exactly. I have never seen
It's
this.
too much.
So this happens, again, it doesn't happen when you're doing side-by-side code review.
Well, not when you're doing it. Well, if you do it for the first time in some teams, it might happen. So I agree that you need to facilitate the process of code review and you need to start it in a certain way, but then everything should go fine. And it could be the team leader or someone else who does that inception phase.
Yeah, and that's actually
all.
That's actually a very good point, because the more experienced programmer from the team should set the tone of the code reviews. Right? And this is very important. And it has to be fair. serious but fair. So if you find an issue, say you found it. If you have a question, ask the question. If you have a comment, no. Another thing that I've noticed, it's very useful to figure out how to, when you're doing reviews and when you give feedback on code, to separate between things that are issues and explain what the issue is and why it is an issue and what the consequence is if it's not obvious or if it's not documented in coding guidelines. But the second thing is separate this from preferences. So I would say in a code review, I would have done this like this, but it's a personal preference. And then have a conversation on that, because once again, the goal is to learn. If we learn more about each other's personal preferences, we get a chance to also adjust them in time. So work better as a team. All right. So I'll say this is one. The other one is, I found it interesting because it's written by Trisha Gee, or Trisha Gee, right?
Yes.
Java champion and IntelliJ IDEA developer advocate. She has a lot of interesting talks. She is a very good speaker. So, and let's see, ways to make code reviews more effective. There are many things a reviewer can look for when performing a code review. A team should identify what's important to their project and consistently apply those checks during a review. Yes. So this one makes much more sense to me. Human reviewers are very valuable, so automate everything you can. Formatting, style, checking for common bugs, identify common security issues, and running automated tests.
Of course.
Yeah, so I agree. Human reviewers are very valuable. Absolutely. And the problem is, there was a comic at one point, I think, but I'm not sure if it was XKCD or I couldn't find it before we started. But basically the idea was that when you have a 5-line code review to do, then you find a bunch of issues. But when you have 500 lines, there's no issue. And you just, okay, move on. So it's also a matter of attention, right? And do these things. Yes, set up all these things first. If you don't have these things, then of course your reviews are annoying. Because you need to look for everything that you could look for automatically instead of, you're doing the computer's work. When it comes to performance, understanding the system's performance requirements are key to knowing which potential issues to look for during a code review. Yeah, that's a good one, actually. I've seen a lot of developers, in particular C++, right, that would optimize everything.
Even too much.
Yeah.
So that it's not optimal anymore.
Yeah, so they would look at a piece of code and say, oh, but that's not, you are using too much memory, or, and not every part of your code needs to be particularly performant, right? I mean, you shouldn't do very silly stuff like occupying the whole memory or things like that. But when it comes to performance, your core review needs to start from the requirements from the module that you are in. And those should come from your architect. If not, if you haven't figured them out, then it's an architecture responsibility to figure out what are the requirements for performance. Typically the response time, but it can be something else.
Mm-hmm.
Some simple checks by a human code reviewer can dramatically improve an application security. This would be interesting to see in more detail. I think it's true, but on the other hand, many of these things you can do with static code analysis, tests for security. But yeah, maybe there are a few things that can be seen by a reviewer. A code review should be a collaborative discussion, not a battle. Deciding upfront what is important and what's not can reduce conflict and manage expectations. There's another technique here that you can use, which is to have focused code reviews instead of a code review that looks at everything. So what I mean by that, you could have a code review on making sure that everything works and that all the fundamental guidelines are followed. But then you could have a code review that is focused on design, a code review that is focused on security, a code review that is focused on performance, right? And these will tend to be shorter and smaller than if you have one big thing with everything, particularly when you have little automation. So, okay, let's see. And she actually goes into detailing a few guidelines. Well, more like heuristics, let's say, not necessarily guidelines. What to look for. How does the code fit with the overall architecture? Does the code follow solid principles, domain-driven design? What design patterns are used? Are these appropriate? And so on. Readability, functionality. Have you thought about things? And I'm just curious if there's anything, because she says something on security. A surprising number of security checks can be automated and therefore should not need a human. Yes, SQL injection, cross-site scripting, you can automate those. It's easy, just write some tests that try to benefit from these issues. But I think things like encryption, secret management, logging and auditing, those are harder to verify automatically, right?
Mm-hmm.
And at the end you'll need anyway some pen testing if you are serious about security, no matter how much reviews have you done. All right, so I think I don't want to go into more articles on this, but perhaps let's dive a bit into weirder ways of doing code review. The first one is pair programming.
Yeah, well, that's, I think, the best one, where you in a way mix coding with reviewing.
And you've also written the book on remote pair programming. Did you have any ideas there on how to focus on code quality while doing remote pair programming?
Yes, of course, because it somehow result if you apply these practices well, these practices of remote pair programming, and you do have an increased quality as long as you have the skills to know that. So that's why probably an anti-pattern is to put to very beginners, to beginners that are at the beginning of their career, maybe to put them to pair on a topic because they won't know what to look at.
Mm.
So that's probably an anti-pattern. But otherwise, I think you do have a better quality. And in fact, what is interesting is just by talking before you write the code on what you want to do, that's the strongest thing. It brings the discussion on what you should or shouldn't do, or what would be a better solution. So in a way, you could imagine that that's a code review on a code that wasn't yet written.
I think somebody said, but I don't know who, that pair programming is code preview instead of code review.
Exactly, yes. That's the idea. So in this way, you will have a better code just because you are constantly talking about what you need to do and how to implement and what are the options. And typically, two people would choose a better solution while talking also, while discussing about their solution, than just one person writing that.
And on that note, the next and probably the weirdest way is doing some kind of group programming.
Yeah.
And here you have things like Coding Dojo or mob programming, ensemble programming, whatever it's called now.
Yes, exactly. So again, here you have even more people, and it's, I would say, almost impossible to get something missed as long as you have, again, if you have only juniors, probably you'll have many things. But if you have people who have a bit of experience, you'll have a very good code. And I think a very interesting thing here about code review is the point of view of testers. There's this branch of manual testing, which is called exploratory testing. And while talking with testers that do that and are very experienced, they said that they like to pair with programmers because for them this is exploratory testing. So looking at how a programmer writes the code and giving suggestions is a type of exploratory testing that's done during or even before the code was written.
I've never thought about it like that, but it's true. Because as a tester, you try to figure out what issues might have been introduced in the code, but you can also look proactively before the issues are actually introduced to figure out what will happen. Right?
Yeah, so it's the idea of shift testing left, and you don't shift just automatic testing, which we're doing with continuous integration and acceptance test driven development or specification by example or behavior driven development. But you're also shifting manual testing because you consider exploratory testing as even part of the code writing process.
So it's an exploratory testing driven development.
Yes.
That sounds like a very interesting thing to experience. You'd have to do it with testers who have a good grasp of exploratory testing and programming. Right, but it sounds very, very interesting indeed.
Yeah, there's a very interesting, I think, talk, or you can hear about these things from, he's Dutch, so I'm going to pronounce his name in a very weird way, but Huib Scholz, probably you would pronounce in Dutch in a very different way, but I cannot do that. So he is very knowledgeable on these areas on exploratory testing and using a very wide way exploratory testing.
All right, so I think we covered code reviews. Anything else you'd like to say as a conclusion?
Yeah, to conclude, I'd say that code review brings value. Don't treat it as an overhead or as something that takes time, and try to maximize the value of this activity. It always brings value in my view, even if you do it offline with Git and so on. It's better to do it than not doing it, but it's even better to do it in person or remote and looking at the code. And as you mentioned many times, it's good to treat it as a learning process. So optimize the value of code review, and it will you'll see the big benefits. That's my idea.
Right. Feedback is how teams learn. And I mean the team as a system, not only the people.
Mm-hmm.
And code review is a form of feedback. But you can learn through all the other forms of feedback as well if you take them seriously and and actually have these cycles of feedback. Absolutely. Yes. Cool. So this is what we had to say about code reviews. What do you think? What are your ideas? How are you doing code review in your organization? Have you tried doing pair programming, or have you tried doing code reviews that are, in person instead of writing comments on pull requests? How does that work? What are those challenges? Let us know in the comments. If you have any more questions, we'd be happy to answer those. So this is it from us. If you like this video, leave us a share, subscribe to the channel, leave us a like, share with other people. And until next time, remember to think, design, and work smart.